Okay, today we're going to continue with the topic of classes, and we'll pick up where we left off last time, which is in Lab 5, right here. And in our last meeting, we worked through exercise 1, which was to create a class called number. And then we wrote some test code to test that class. Let's just review that for a moment. So here's my Lab 5 folder. There are a number of files that added together comprise the solution to exercise 1. And maybe the starting point to think about these files is this file ex1.cpp. That's the main program. It has the main function in it. That's the starting point when your program starts to execute. The operating system looks for that main function and passes execution into it. And then there's the header file that defines the interface to our number data type, our number class. And then there's the file number.cpp that provides the implementation of the functions that are in the class. And let's take a look at the header file. You'll see in the header file is some documentation. This is called a UML class diagram, UML, Unified Modeling Language. It's a kind of a standard notation that software developers use to describe what classes look like, how they function. And there's 3 regions in our UML diagram. There's the name of the class, that's in the first region. There are the member variables, which comprise the state of instances of the class. And here we see a single member variable whose name is n, and it's of type int. The minus sign means that the variable is private. Only functions within the number class itself can access that variable. Any code that's outside of the number class cannot access that variable n. Now we have 3 functions, 3 member functions. These are functions, they're not in global scope, they're not available to, they're not callable on their own. They have to be called with reference to an instance of the class. The first one is a special function called a constructor. This creates instances of our data type. It provides the instructions that are executed to initialize instances of our data type. And we need to know when we create an instance of the number class, we need to pass in the integer value that the instance will represent. So we're passing n here. That n is then assigned, the value that gets passed into the constructor is then assigned to our private member variable n. This is also referred to as an instance variable because it's a variable it represents allocated memory for each instance of the class. We create 10 instances of a number class, we will allocate 10 separate integer storage locations, or 10 separate locations, or 10 separate allocations to store integers. And then we have the regular functions, non-constructor functions, is prime, and that returns a Boolean value. And that's if the number that the instance represents is prime, this function will return true. Otherwise, it returns false. Then we have a function called is divisible by. This is different than is prime in that it has an argument. It takes an integer. So we want to know whether the number we're representing is divisible by the number that's being passed in to the function. If the number we're representing is divisible by the number k that's being passed in, then we return true. That's the Boolean data type here. Otherwise, we return false. These have plus signs in front of them to indicate that these are public functions. So you can access, code can access these functions anywhere in the program, not just from within functions in the number class. And here's a description of the what's called the interface to the class. As you can see, there is a public section and the private section. Actually, you wouldn't call the private section part of the interface. So this is called a class declaration. It declares what the class looks like. It doesn't give information about how the functions work. It just says this is a list of functions that the class has. These are the arguments, these are the return values, these are the names, these are the member variables, this is what's private, this is what's public. That's it. But I'm not going to specify here how isPrime is implemented, or how isDivisible_by is implemented, or the constructor either. We could actually put the implementation here in the header file. That's okay, but we didn't do it that way. We're following perhaps the most typical organization of code. So there are different ways of organizing the code. We're just looking at what is the most common or typical. Then we have an implementation file that simply, there's three things that are defined in here. There is the constructor that shows the implementation of the constructor, the isDivisible_by function, and the isPrime function. So it's this file, which ends with .cpp, that provides the implementation for the member functions. And then we have the test code, which has the main method. So that's the entry point in the program. And the purpose of our program here is simply to test our number function, our number class. So you see we need to include the header file for our number class so the compiler knows what the number class looks like. We create an instance here. We call the instance 9 and pass in the value 9 to be consistent with its name. And then we have a number of assert statements here, just to check that the class is functioning correctly. And then we get to a second instance, where we're calling the constructor a second time, so we create a second instance of the number class. This instance represents the number 7, and then we have some test code to verify that, that the class works correctly for the value 7. And then we have several more instances, and if we pass all of the tests, then we print all tests passed. So we have test code that tests the correctness of our number class instance, or our number class, rather. That is exercise 1. Now, exercise 2 is asked for a file in with the name ex2.cpp that has a main method in it. And this program that we're going to write will use the number class that we just built and tested in exercise 1. And what this program will do is the same thing that we did in a previous lab. This lab here on lab 4 on functions, we worked through this exercise 2. We wrote a program that prompted the user for an integer and then printed all the prime numbers between 2 and the integer entered. So we're going to reorganize. This is actually, in this exercise here, we did this problem in even an earlier lab, I think it was lab 3, where we didn't use functions. And then in this lab, we reorganized the code to see how much easier it is to solve the problem with the use of functions, because we can organize the code so that it's more readable. It's easier to understand or reason about. Now, in the current lab, we're going to solve the same problem a third time. We'll have exactly the same behavior as apparent to the user, but internally it will be different. Now, in addition to using functions, we're going to use the number class. We're going to see what a program looks like when it's organized around classes and objects. So I'm going to start by copying the code from Lab 4 that solved that second exercise. And let's test it. Enter in the number 8. The prime numbers between 2 and 8 are 2, 3, 5, and 7. That looks good. So we're going to keep the same behavior. We're going to keep the same sort of appearance of the program, but we're going to change its internal organization. Let me open another window here. Here's the program with the test cases. Here's the function isPrime. Now, this function is inside of our number class. So we're going to use our number class and not use the isPrime function that's part of this main. Now, to use the number class, we need to include it. We need to include the header, rather. All right, now the compiler has a definition for our number data type. And here's the main. We prompt the user to enter a number greater than 1. We read it in. That will stay the same. And then we have this loop where we start at 2 and we go up to and include the value k that the user entered in. And we check to see whether the number is prime or not. Well, this time we're going to do this a little bit differently. We're going to create an instance of this number class. We'll call it, I'll call it num. We'll pass in n. And now, we use the isPrime function of the number class to determine whether the value n that's part of the loop, to determine whether that n is prime or not. That's the change. So, we had to add a line here, so that's a negative. But we were able to omit the isPrime function. So we have achieved some degree of simplification. The number of lines in this ex2.cpp file have declined. So let's try it. It should just work. Oh. That's the problem. I know the problem. Should have told me what the problem is. Anybody remember from last time? First of all, I want to tell you that this is not a problem with compilation. See that LD right there on OS 10 and Linux? That's the linker. It's a linking problem.
Just because you didn't link them, like compile them together at the same time.
Exactly. So the compiler's only working with this one implementation file. We need to list the other one as well. That should do it right there. Works the same. We did it. Any questions about this one? Okay. Remember to run git pull when you sit down to work. I like to use git status to see what changes there are. By the way, I don't want to add this. This is untracked files. I don't need to track this file that that OS 10 inserted in my folder. You'll see that file has a leading dot here. That's so the intent there is for that file to remain invisible. So if I do an ls, I don't see it. I'd have to do ls -a for all to see that file. That's referred to as a hidden file. Windows has a different mechanism for hidden files. Linux uses the same mechanism that OS 10 uses. So let's add number.h. That was modified. Did I modify number.h? And let's add ex2. We're adding the changes to these already existing files. Actually, ex2 doesn't. Number.h was existing, and we added the revisions to it. ex2 is new, and we added the new file. So I committed to my local repository, and I'm going to push to the remote repository. All right, that's it for this lab. There's a quiz coming up on February 19th. And the quiz will resemble Lab 5. Well, it also resembles the assignment 2 here on classes. You need to start working or have already started this assignment 2 on classes. But that's due on February 16th. So I'll review the answers to that assignment the next day, February 17th. That's Monday, right? It's February 17th, Monday. Okay. You got to get that in by Sunday night. So what I did this morning is I created some practice problems for you to work on. Well, it's one problem, really. And this is a problem from a previous quiz that I gave. So it's called the school bus class. But I thought what we could do today is to go through this, unless anybody else has unless somebody here has another suggestion. We just stay on classes, go over that with another problem. Make sense? Okay. So actually, let's do this as an assignment and simulate what it'll be like when you're taking the quiz. Okay, so that means we're not going to be running the compiler. We're just going to give our answers by reading the questions and penciling down the answers. But I do encourage you to also try to implement the class as well, just to learn the material better. All right. Learn the material more thoroughly. That's a better statement. So here is, let's take a look at this. This is what the assignment 2 looks like. This is what quiz 2 looks like. So I'll give you some description of a class. Here I'm providing what would be in the header file. And then I describe the class here. So the quiz looks just like this. I may actually give the UML class diagram and describe the class. So there's two variations here. So this is the variation where I give you the header file and I give it a a written description of how the class works. And then I start asking questions. And the first one is to draw a UML class diagram for the school bus class. And we have that. Where is that? Let's take a look at that. There it is right there. The name of the class is in the top section. So you have to memorize the structure of a UML class diagram. There's 3 sections. Top section is the name of the class. You can see I just copied the name of the class in there. The second section lists the member variables. Look, there's 2 private member variables, seats and seated students. So you can see seats and seated students with a minus sign here and the data type of int in the second section.
The member variables sitting as the private, whatever's private in the header.
One more time.
The second section is the member variables, right?
Yeah, the second section is the member variables. I'm going to tell you that you can make some of the member variables public if you like. It's not considered good practice, but it can be done anyway.
So you should also put the private ones there.
Huh?
The private ones you put in the member variables area?
No, all variables go here. All member variables go here, whether that's private or public. If it's a variable, it goes in the middle. If it's a function, it goes in the third section, regardless of whether the function is private or public. The minus sign and the plus sign, those are the things that tell you whether it's private or public. It just so happens that all of our member variables are private and all of our member functions are public. I mean, that is the standard situation. But you could also have member variables that are public and member variables that are private. That's also possible. But we're just not showing that here. Now, just like the number class, the school bus class is used to represent school buses. Not one bus, but any number of buses. So if we had like 2 buses, one bus could fit 30 students, another bus could fit 40 students, then we would create 2 instances of the school bus class. And one instance would have seats set to 30, and the other instance would have seats set to 40. So you can think of these class instances as models, little representations, models of some real thing that's of interest that we're trying to reason about or to attach information to and to process as a part of a larger data processing system. You can imagine if you were in a company that had accounts, you could have a class called customer account. And in it, would be balance and customer name and all the information that you would want to organize and group together and attach to what you think of in business terms as a customer account. So here we have a school bus. Now we don't need to represent all the details of the school bus. How many cylinders the engine has, what the year, the make, the year that it was constructed. If we needed the information, we would put it there. So we just as needed. So we put the information as needed by whatever problem we're trying to solve. Now, it's hard to sort of remember that because it's a very artificial problem. We're just starting out here trying to learn the syntax and technique of C++ programming. So we can't start with a large program. It would be too complicated. But trivial programs like this, it's hard to make them realistic. Well, you can think that we have maybe some kind of a school bus data processing system, and we need to create instances of school bus objects to represent their capacity and how many students are currently in each bus. So the first data item is seats, how many seats the bus has, that's the capacity. If it's 40 seats, it can only fit 40 students. Standing room is not allowed on the bus. And, or standing is not allowed on the bus. Seated students is the other data item. That's how many students there are in there that are in seats. And then we must always have a constructor. And here the constructor, remember the purpose of the constructor is to initialize instances of the class. And so we need to know how many seats the bus should have or has and how many students are currently in there. So when the constructor runs, it will initialize the two member variables to the values passed into the constructor. Then we have a function called add students. So if the bus pulls up at a bus stop and 3 students want to get on, then we can represent that event by calling add students, passing in the number 3. Now if there are only 2 seats available, only 2 students get to sit down and 1 student can't get on the bus. And so we indicate that in code by returning false, saying something went wrong. We couldn't add all the students that you asked us to add because it would have exceeded the capacity of the bus. So that's the purpose of the return value here. Well, I should swing that out. If there are 3 empty seats and you try to add 5 students, then add students returns false and does not change the number of seated students. Okay, so that description there is a little bit different than how I just explained it. If the bus pulls up and there's not enough seats to hold all the students, no student gets on. That's what we're modeling here. We're not modeling the situation where we fill as many seats as we can and the others are left behind. So we just leave it. We can't serve all of the students, so we don't serve any of them. And we return false in that case. So it all depends on the problem requirements. If we were supposed to implement it the other way, we could implement it the other way. This all depends on what we're trying to model. All right, so let's go through and look at the next problem. Provide an implementation of the school bus constructor. I don't have the answer there. Because like I said, I just did that this morning. So I'm going to type it in here as we talk. And then you'll have a record of it to look at later on when you study. So we have the school bus constructor. The school bus constructor looks like this, right? Actually, I'll grab it like this. How do we implement this constructor? Well, in an implementation in C++, the data type comes in front of the variable name. So we need to reverse that. And remember that we need to initialize the state of the member variables. Right here. We have 2 member variables, seats and seated students. So the member variable seats can unambiguously be represented with that syntax, this arrow seats. And we set that to the locally scoped seats variable. That's a parameter in our function. And we do the same thing for seated students. That's the constructor. The constructors in this class are all going to be pretty much the same thing. You don't have to do anything other than copying a value that's passed into the constructor into a private member variable. That's, you know, in other situations, constructors may do more work than this, but that's what we're doing. This is the basic responsibility. And that's all we're going to use in our constructors. Now, notice we're not checking for bad data here. So it could be that the code is passing in a number of seated students that exceeds seats, and that would be an error. But we're not checking for that. So we're not validating the arguments to the constructor. All right, what about the next one? Provide an implementation of the getStudents function. All right, that's this question here. What about this function, getStudents? GetStudents returns an int. So it looks like this, int getStudents. Now getStudents doesn't, oh, I didn't show that in there, did I? Actually, what I want to do is change this example. GetStudents is an example of a const function. You can call it and it won't modify the state of the object. So you remove students can modify the state of the object. Add students can modify the object. But getStudents just, it's like a read only. I'm only reading. I can't modify anything. So we tell the compiler that's our intention. And the compiler will enforce that restriction. So that if we were to make a mistake and try to modify something, the compiler will complain about that. So, you know, functions have return values. So the getStudents is a function that returns an int. So we want to return is it seated students? I could have called this just students instead of seated students, and then getStudents would maybe be simpler to think about. So maybe the name is not that great. But I'm not going to refactor too much right now, so we're going to leave it alone. That's called refactoring. So if I look, I see, oh, I got a bad name. I can get a better name. Make the code easier to read. And then if we change the name to improve readability, that's a process called refactoring. And it's important to be refactoring all the time. It's like cleaning your house. Like if you say, oh, you know, that chair doesn't really belong in the hallway there. Everybody has to walk around it. And let's put it in a better spot. And that's like moving your furniture around and then feeling good after you do it because, wow, things work so much better now. So that's called refactoring, and that's a very important sort of habit to get into when you're working with source code and you work through it over and over again. You're always cleaning it and improving its readability all the time. So there's a readability issue there. You know, the member variable could have been called just students to mean the students that are seated, actually. But the name seated students, that expresses something as well, the fact that these are students that are in the seats. So, you know, it's just something to think about. So now we're using this here to indicate that seated students is a member variable, as opposed to, you know, a locally scoped seated students variable here. But because there's no name conflict here, we could actually chop off this. Because there's no locally scoped seated students. The function doesn't have seated students defined in it like the constructor does. And so we don't need to prefix the value with that this symbol. What about the next one? Provide an implementation. So we did that one. Provide an implementation of the add students function. And it was hard to read this. Sorry about that. What I can do is, in case you're working there in your seats, I will I'll just look at that. I can commit my changes to my web page using Git. So now if I refresh this, now you have the work that we just did here. So you can look at that as I commit them. You see that? I have a website running on a site called GitHub, and I can basically I have a remote repository there, which the web server is pulling data out of to display the web pages. So I can push my changes to my web pages into that remote repository, then they become visible. So it's very convenient. It's a software development technique that's kind of current these days. You see other systems that are following this pattern as well. All right, so we looked at this one, and we looked at this one. What about the add students? We don't have that one yet. Provide an implementation of the add students function. So add students returns a bool, and it takes students. Is that how we did it? Add students returns a bool here, and it takes an integer number of students. So we need to add these students. These students are getting on the bus. Let's do this kind of the simple approach first, and then recognize the problem and then fix it. So we have seated students. We have a current seated students is a variable that represents currently how many students are on the bus. So what we want to do is add students. So we do plus equals students. See, this students here is the locally scoped, is the variable students that scope to the function. This variable here is the variable that's scoped to the class. Once again, we could do this. If this, and I'll tell you, some programmers do this. They'll actually put this in there just to be absolutely clear, just to be explicit about the fact that the variable is a member variable, and it's not scoped to the function or globally scoped. Now, what happens when we do this? What would you say to that if you were a compiler? Does that make sense? Well, there is no member function students. There's no member variable students. There's seats and there's seated students. So this one it might compile. Does it even compile? No. And so there is no member variable students. So this doesn't make sense. The only variable students that exists at this point is the function parameter students here. All right, so that's it, right? Oh no, here's the problem. What happens if we're trying to add too many students? Remember, we have to only allow this operation when the result doesn't exceed the number of seats on the bus. So let's put that condition in there. So if seated students plus the students to add exceeds the number of seats, then we have a problem. then we're going to return false to, to let the calling code know that the operation has failed. Otherwise, we're going to add in the students requested, and we'll return true to let the calling code know that the operation succeeded. I'm going to clean up my HTML code here. Sometimes that function, that's a little slow. Let's see if it actually updated. Ah, did not update yet. Did not update. We have to wait a few minutes for that. All right, let's look at the next one. Provide an implementation of the remove students function. Here's remove students. How many students take off the bus? That returns a bool. How many students to remove? Whoops. Make some spaces around there, it's easier to read. There's our function. Let's do the simple approach first and then fix the problems. We have seated students, and we want to remove students. Right? Maybe we have 10 seated students, and we want to remove 2 students. 2 students are getting off the bus. So we want to take 10 and remove 2. What happens if we have 2 students on the bus, and the code tells us to remove 10 students? Oh, this wouldn't work, right? Because we can't remove a negative number of students. So we have to check for that. So if some condition, then we want to refuse to do the operation, we return false. Otherwise, some condition that says there's a problem, then we'll return false. Otherwise, we'll do the operation and return true. But what's the condition? What's the condition? How would you think about it on your own right now? How can you express that problem, that the number of students the calling code is telling us to remove, that exceeds the number of seated students? So we can't remove those. What is the expression to use? You know, a lot of students don't get this. That's why I'm pausing at this point, and I want you to think about this. It's not that tough, but it's new thinking for you. Does anybody know the answer to this?
The students can't be greater than the seated students.
Exactly. How would you write that? Tell me what to type.
I'm not seeing the other one, but it's like the students that you removed. What is that?
Yeah, just tell me what to type.
Students can't be greater than.
Yeah, you're getting there. You were like so close. So you got the English. Now you need to sort of translate it to computer speak. You got it. Somebody? What do I type?
Students greater than seated students.
Exactly. If students, that's the number of students to remove, is bigger than the number of students on the bus, we can't do it. That's not that bad, right? Can everybody grasp this? Really, last quarter, half the class couldn't get this. You know, on the day of the question, in the lecture, if you don't get it, that's fine. Okay, don't sweat it if you don't get it now. But review this and understand this on your own, and then get it on the assignment. Get it correctly on the assignment, and get it correctly on the quiz. You can do it. Well, you have to think about it till you really get it. All right. All right, number 6. Let's read it here. Provide test code for the add students function. You implement it in problem 3. Oh yeah, well, add students function. Use assert statements for this purpose. Make sure the test code executes all lines of code in the function. Provide test code for the add students function. All right, ready for this? Well, obviously, we need to create a school bus instance. We'll have 10 seats with 5 students on board. All right, this is the number of seats. This is the number of seated students to start with. And right off the bat, let's just do this. Let's do bus 1. You know what? I'm just going to call it bus. We'll just use one instance. So I'll just call it bus. I won't do bus 1, bus 2. There's a get students function. There should be 5 students. So we can check that. Make sure the constructor's working correctly. Now let's add some students. Let's add 4 students. Now, add students returns a Boolean value, right? Add students. What we need to do, we're writing code that tests add students. We want to test add students. And look, add students returns a bool. Now, when we try to add 4 students to a bus with 10 seats and with 5 students on board, then that should succeed. So we want to use the assertion here. So an assert that this is true. Because you don't have to do equal true, you can just do assert, but maybe this is easier to read. And now there's 9 students. Well, let's test that. Let's test that get students returns 9. So we're writing code that these assertions should just quietly succeed if we wrote the code correctly. What happens if we try to add 3 students? That returns false. And if we call get students after that, what do we get? We get 9. Right? So it didn't change the number of students. So there it is. That's, for me, that's enough test code for this problem. For those who are looking at it, I'm going to, I do this too often, I think it slows up the speed at which the site updates. Oh, there's add students. That's remove students. That's not there yet. You have to wait. It's a delayed. You know, it takes a lot of processing back there for the change to make its way through to the website. So, did we do that right? Provide test code for, just add students. I'm not asking for test code for remove students, just a test code for add students. All right, here's another one. Provide an alternative, so this is number 7. Provide an alternative implementation of add students that sets the number of students seated in the bus to its maximum. When the added students exceed the available capacity, the function should continue to return false in this case. So now the bus has got 10 seats. There's 8 students on the bus. It pulls up to the bus stop. There are 3 students that want to get on, but there's only 2 available seats. So this time, the bus driver lets the 2 students on, and 1 student doesn't get to go to school. Don't you wish you were that student? No, anyway. And the function returns false, saying, you know, I did my best, but I couldn't do everything that you wanted. I couldn't add all the students. So I'm going to return false as an indicator that that event happened. So we're changing the requirements for the program. We're changing the requirements for this school bus class. Now let's re-implement the the add students, right? Let's re-implement the add students function to provide this alternative functionality. And let's just grab the code here. There's add students. So here's add students. Let me add some spaces around there so it's easier to read. So now, if this is the case, we're still returning false if we're being told to add too many students. But we want to fill all the seats that we have. This is okay, right? If there's 5 available seats and we want to add 3 students, no problem. We just add it into seated students, return true, we're done. But if the problem is this one. Here, in the previous implementation, we did nothing with seated students. Now, we need to adjust our school bus instance so that it shows the bus is full. What line of code do I add here for that?
Get students, it'll be 10.
No, we don't call get students. This is another really simple answer that's very hard to grasp and understand at your point in the learning process. So I'm pausing here. I want someone to hopefully tell me what line of code we need to complete this function. What do you think? You're good. You couldn't write the last line, but you understood that. You were just a hair away. What do you think we need to do there? Remember, there's 10 seats. There's 10 seats. 8 students are on the bus. And we want to add 3 students. We can't add all 3. You can only add 2. So we got all 10 seats are full. How do we express that in code here? And I want to tell you, it's very, very simple when you see the answer.
Add students.
Huh?
Add students.
So I couldn't hear that.
Add students.
Add students. Tell me what to print, what to write here. What's the line of code? How do we add those students? Yeah.
Is it seats less than add students?
What that?
Seats less than add students?
You know what? My hearing is horrible. I'm getting old. Can you one more time?
Would it be seats less than added students?
Seats less. What?
Seats less than added students.
Seats less than added students. No, it's not a condition. There should be an operation here. That's not it. Well, look, what? Think about it. Think about it. Okay, we've got a variable called seated students. It equals 8. And in the scenario I'm talking about, the seated students is set to 8. The seats is set to 10. We call add students with 3. What does seats equal afterwards? 10. Seats doesn't change. What does seated students equal afterwards? Huh?
11.
No, it can't be 11. We can't.
I know.
No, 11.
They exceeded 10.
Huh?
Do it
10. 10. All right, so let's suppose another example. Seats at 10. Let's leave seats at 10. Seated students is 8, and we call add students with 50. What will seated students be equal to when we're done? 10. What will seated students be equal to? Whatever number we pass in, as long as it exceeds the capacity. 10. What should I write right here?
10.
Good one. I wish I could. That was a good one. But no, what? Seriously, what are we going to write here?
Seated students equals 10.
Is that right? Huh? No, there's no 10 in the code, right? That's just our imaginary example here. So we took something from our imagination. Yeah.
Use seats.
Seated students equal to seats.
Exactly. You got it. You got it. We got there together, though, didn't we? We did this as a group with jokes involved there, too. So that is it right there, right? See? You see how we reason through, we get that, clean it up, and that works, doesn't it? All right. That's great. We want to do the same thing with remove students. We're almost at the end. Let's do this quickly. The same alternative. You know, we're going to return false, but we're going to, we're still going to do the best we can. And let me grab this. Same problem. Well, not same, similar problem. Okay? Remove students. The bus, let's use our 10 example. The bus has got 10 seats. There are 5 students sitting on the bus. All right? That means seats is 10 and seated students is 5. And we call remove students with 6. What does seated students get set to? 0. We do the best we can, just like the change in our add students function. Now we're going to actually remove as many students as we can, but we're going to return false to say that there was a problem. So what line of code do I need here?
Students equals seated students.
Students equals seated students? No, students is a locally scoped variable. That won't change the state of the class, the instance of our class. Think about what has to be done. Seats is 10. Seated students is 5. When we call remove students passing in a 6, seats remains at 10, but seated students becomes 0. What happens if we pass in 1 million to remove students? Seated students will be 0. So what line of code do we put here?
0.
That's a stale joke now. Let's flesh it out. What else do we need?
Seated students equals 0.
You got it. You got it. That's it. You went too far. Isn't that it? Doesn't that agree with our thinking, our understanding? Okay.
It's okay to put 0 but not 10.
Professor?
Yeah, it's okay to put 0 but not 10, exactly, because 0 is the opposite of seats. Yeah, question?
You spelled seated wrong.
Well, I want to tell you that on the quiz, there's no problem with spelling error. Yeah, you're right. The compiler wouldn't like that, but we're not submitting to the compiler. It's okay to use 0 because 0 is special. 0 is like seats. Seats is the upper limit, and 0 is the lower limit. So the value 0 is very similar to the value seats. It's not a 10. You see, I know, that's a very good question, actually. It's a very good question. So let's go to the next one, because we've got to finish this up. Provide test code for the remove students function. You implemented in problem 7. Use assert statements for this purpose. What? Problem 7 is to implement add students, not this. I should change that to add students. So I can do it right there. I've got the web page right here. So this should be provide an alternative implementation of the add students function. All right, let's, sorry, that's not right. It's this one here. Provide test code for the add students function you implemented in problem 7. So that's the alternative version of add students. Let's copy the existing test code. And modify it. All right. I think we can use the same example. So we create a bus of 10 students. We get the students should equal 5. We call add students with 4. That returns true. Then we call get students and that gets 9. All that is the same. Now when we add 3 students, does the new version of add students return false? Yes. Yeah, so that's good. But when we call get students afterwards, it should be 10. And that's it. That's how we express that difference in the test code. And that's it.